2.8. The prime factorization of 2020. So the prime factors are 2, 5, and 101. And the exponent for 2 is 2. The exponent for 5 is 1. And exponent for 101 is 1. Now this number 2020 is multiplied with an integer n, where n also has the same prime factors. Two has a power a, five has a power b, and 101 has a power c. So the number 2020 times n will have 2 power 2 times 5 times 101 multiplied by 2 power a times 5 power b times 101 power c. And if I collect all the factors of 2, that becomes 2 power 2 plus a times 5 power 1 plus b times 101 power 1 plus c. Now this number 2020 times n, this will be a perfect cube number. That's the intention. So how do we make this 2020 a perfect cube number? When individual prime factors 2, 5, and 101, these prime factors, they are individually having the exponent which has a factor of 3 in it. So it is in this fashion. So 2 has an exponent which has a factor multiplied by 3. That factor may be 1 or 0 even, times 5 the factor again is something multiplied by 3, and finally it has something up here multiplied by 3. So that's the intention, so that the whole thing is a cube number. So that will make it a perfect cube. Now these parts are empty parts. They're unknown so far, so I don't really know what those are. Now let's go back to the same problem statement and let's see. There are two things that are mentioned, that n is an integer and the a plus b plus c, the sum of those three exponents a, b and c, have to be the least possible value so that 2020 times n can still be a perfect cube number. So if I have n as an integer, then I can write a statement. Let's put a pause to this particular argument and continue here. So if n is an integer, then we can write a is greater than or equal to 0, b is also greater than or equal to 0, and c likewise is greater than and equal to 0. That means I cannot have a less than 0 or b less than 0 or c less than 0. Why? Because if a is less than 0, then if you notice, n becomes a number which is divided by 2. So it is 2 power, let's say a is negative 1, then it becomes 5 power b times 10 or 101 power c divided by 2. And we know that 101 and 5, these are prime numbers, and when divided by 2 they will not become an integer. So then that means that any negative number in place of a or b or c will result in a fraction which is not an integer. So if I am giving the condition n as an integer, then I have to have a greater than 0 or b greater than 0 or c greater than 0. I should say a greater than 0 and b greater than 0 and c greater than 0. I can write the argument here. Otherwise, n becomes a fraction. So that means the sum a plus b plus c, therefore a plus b plus c must also be greater than or equals to 0. Now let's go back. So from here, I can also say that 2 plus a has to be greater than or equal to 0, and it also have to be a multiplier of 3. Now remember that a has to be 0 or greater than 0. If I put a as 0, it becomes just 2, which cannot be a multiplier of 3. So the next number that can be a multiplier of 3 will happen if a is equal to 1. And I can even make a equal to 4, which makes it 6. That also is a multiplier of 3. But also remember that a plus b plus c have to be least. So in order that the a plus b plus c have to be least, I need to have the smallest possible value of a such that 2 plus a is a multiplier of 3. So this basically means a equals 1. And then from here again, I have 1 plus b. That is again a multiplier of 3. And then this means b has to be 2. And I also have 1 plus c here in the same way as for b. So a plus b plus c is 1 plus 2 plus 2, which is 5, is the least possible value. So answer is 5.